Alright, in this video, we are going to be looking at differentiation by formula method. And the formula method of differentiation states that for any function, y equals ax raised to the power n, dy dx equals power times coefficient, which is n times a. Alright, rewrite the term you're differentiating with respect to, which in this case is x, all raised to power minus 1. Alright, so we have dy dx to be equal to na x raised to power n minus 1. So this is the formula method of differentiation. To understand this better, all you need to know here is that you multiply your power by the coefficient, then subtract 1 from the power. So if we have, let's say, v equals s 2s raised to the power 3 in this case, this is going to be dv ds, not dy dx again. All right, we had dy dx here because we are differentiating y with respect to x. All right, but in this case dv ds because we are now differentiating v with respect to s. So we have dv ds equals power multiplied by coefficient. We have 3 times 2. Rewrite the term you're differentiating with respect to, which is s. Subtract 1 from your power, which is 3 minus 1. That's just it. So our final answer here will be dv ds equals 3 times 2, which is 6s raised to the power 2. That will be your answer there. So let's look at another example. If we have, let's say, a equals minus 12b raised to the power 6. All right, in this case, we are going to be differentiating a with respect to b. So this will be dA dB equals, again, we use our power multiply the coefficient. The coefficient is simply the number attached to the letter here. All right, the same thing here. N is like the number, a is the letter. Yeah, we have 2 as the number, s as the letter. So multiply the power by the coefficient. So we have 6 times minus 12. 6 times minus 12. Then we have b, which is the term we are differentiating with respect to. We'll write our power, which is 6, then subtract 1 from it, minus 1. So our final answer here will be minus 72 b raised to the power 5. Now moving on, we have here if y equals x raised to the power minus 3 over 2, then dy dx is, they gave us a couple of options here. So we'll still apply the general formula because we have everything to be in the form y equals x raised to the power minus 3 over 2. All right, don't forget you apply the general formula or the formula method of differentiation whenever you have your power written out and then you have your coefficient. Our coefficient here is 1. All right, whenever there is no number, we take it to be 1. All right, x is the same thing as saying 1x. So in this case, we are differentiating y with respect to x because we have y and x here in our formula or as the letters here. So we have dy dx to be equal to power times coefficient, which is minus 3 over 2 times 1, and that will give us minus 3 over 2. We rewrite x, so we have x raised to the power minus 3 over 2, then subtract 1 from the power. All right, so that will give us minus 3 over 2, x raised to the power minus 3 over 2 minus 1. If we solve this, gives us minus 5 over 2. All right, so our final answer here is minus 3 over 2x minus 5 over 2, which is option D. Now our next question here says if y equals 4x cubed minus 12x squared plus 3x plus 12, find dy dx. Now this is very easy. All you need to do here is, if you observe very well, we don't have a single term like the cases we've been looking at. where we had something like v equals 2x raised to the power 3. On the right hand side, we had just a single term. But in this case, we have 4 terms. First term, second term, third term, and fourth term. We have 4 terms here. So what you need to do here is just to apply the power rule to each term. Alright, so in this case, we are differentiating y with respect to x. That's why they say find the y dx. So we have the y dx to be equal to, apply the power rule here or the general formula. The power rule of differentiation is also known as the formula method of differentiation. Sorry, I did not mention it at the beginning of this video. The formula method and the power rule of differentiation, they are the same. Okay, so applying the formula method to each one here, or applying the power rule to each term here, all we need to do here is multiply the power by the coefficient, which is 4 here. All right, 4 is the number behind the letter, so it's known as the coefficient. So we have 3 times 4, that will give us 12. Then we rewrite x, subtract 1 from the power, so we have 3 minus 1. All right, so we apply the power rule to this one. Then we go to the next term, which is minus 12x squared. So again, we apply the power rule here. So we have 2 times 12, which is 24. Then we have x raised to the power 2 minus 1. Then we come to this term here, 3x. All right, to differentiate this, we have 3x raised to the power 1. All we need to do here is multiply 1 by 3. So we have 3. Then we have x raised to the power 1 minus 1. Alright, so 1 minus 1 is 0, so that will give us 3x raised to the power 0, and anything raised to the power 0 is 1. Now the power of 0 is for only x. Alright, 3x raised to the power 0 is not the same thing as saying 3x all raised to the power 0. Alright, in this case, this power of 0 is for both 3 and x, but in this case, this power of 0 is for just x. So x raised to the power 0 is going to give us 1, so we're going to have 3 times 1. So this is going to give us 3, whereas if it were to be in this case, 3x raised to the power 0 would have had 1 for everything. Alright, so in this case, differentiating 3x will give us 3x. In this case, like we have here, will give us plus 3. Alright, what I need you to understand here is that whenever you have a term like this, be it 5x, 5v, if you're differentiating with respect to v, 8y, if you're differentiating with respect to y, 8b, 2z, 2z, alright, as the case may be. If you're differentiating with respect to x here, your answer will be 5. If you're differentiating with y here, with respect to y, your answer will be 8. If you're differentiating with respect to v, your answer will be 5. If you're differentiating with respect to b, your answer will be 8. If you're differentiating with respect to z, your answer will be 2. Alright, so whenever you have a case like this where the power is 1, like we have here in all these cases, alright, your answer will just be the coefficient if you're differentiating. Alright, so differentiating 3x, our answer will just be 3. Alright, so that's how we got this. So do not forget that. And then, whenever you have a constant, that's a number without a letter. Alright, in this case, your answer will be 0. So differentiating 12 gives us 0. Okay, so now our final answer here will give us dy dx equals 12x squared minus 24x plus 3. So that's it. Now some of you might be wondering why I said differentiating a constant. Whenever you're differentiating a constant, your answer will be 0. You might be wondering why I said so. Okay, in case you're confused or you want to know why whenever we differentiate a constant, our answer gives us 0. In case you want to know why, drop it there in the comment section. Alright, and I'll make a video on why whenever we differentiate a constant, our answer is always 0. Now moving on to the next video here, we have y equals x minus 1 over x. This is find the y dx. So we have this. It has power to be 1. It has coefficient to be 1. How about this? This is a fraction. So we need to ensure it's in this form, ax raised to the power n, before we can differentiate. Alright, so in that case, we're going to have y equals x minus, to convert this to this form, alright, where we'll now see our power and our coefficient. All we need to do is take the inverse of this. The power of x here is 1. Alright, so if we take the inverse, we're going to have x raised to the power of minus 1. That is based on the law of indices. So if you want me to drop a video on laws of indices, drop it there in the comment section and I'll make a video on laws of indices. All right, so now we can apply our power rule of differentiation or the formula method of differentiation. So we have dy dx to be equal to, this is x, so differentiating x, our answer will be 1. Do not forget the coefficient of x here is 1, all right, and the power of x is 1. And I said whenever you have your power to be 1 and you're differentiating, your answer will just be the coefficient, which in this case is 1. All right, so now moving on to the next one, minus x raised to the power minus 1. So we have minus, now differentiating x raised to the power minus 1, we use our power multiply the coefficient, which in this case is 1. All right, so we have minus 1 times 1, that will give us minus 1. All right, and then we have x raised to the power, we have x raised to the power minus 1. All right, so we write the term we are differentiating, and then we subtract 1 from the power, so we have minus 1 here. All right, so our final answer now becomes 1. All right, minus minus is plus, so we have 1 plus x raised to the power of minus 1 gives us minus 2. So this becomes our answer, 1 plus x minus 2, or you can rewrite it as 1 plus 1 over x squared according to the laws of indices. If we take the inverse of x raised to the power minus 2, that will give us 1 over x squared. So this is our answer here. So with this, we've come to the end of this video. For more videos, please make sure you subscribe to this channel and also drop a comment, like, and share to your friends and your colleagues. I'll see you in the next video.